Hello, in this video, we will be talking about the hypothesis test for one single population proportion using the p-value method. This test is a very specific test. It is called the 1-prop-z test on any TI-83 and TI-84 calculators. That's why I wrote down the 1-prop-z test for a single population proportion, and we will be doing this now using the p-value method. We will learn about how to complete all of these tests using another method later. An hypothesis test involving a population proportion can be considered as a binomial experiment where there are only two outcomes and the probability of success does not change from trial to trial. In order to perform this test, some conditions must be met, and you do recall these conditions from actually the confidence interval. N times the probability of success should be greater than 10, and N times the probability of failure should be greater than 10. However, in any problems that we will do, this will be met, and we will be able to perform this test. I want to point out something else. For a population proportion test, it doesn't matter if we know or we do not know the standard deviation of the population. So in this case, we will always use a z distribution. That's why this is called 1-prop-z test. It's a test for proportion using the z distribution. The formulas for the z test for proportion, which is actually the 1-prop-z test, are following the same general rule for the standard score. The value, which in this case will be denoted p hat, because this is the statistic corresponding to the proportion p, minus the actual value or the true population proportion. And on the bottom, we have the square root of the PQ divided by N. And this is how the standard error looks like when we deal with proportions. But this will be done for us on the calculator as long as we plug in the correct information and we run the 1-prop-z test. In this class, we will be finding the test statistic z and the p-value using the 1-prop-z test. However, if you need to do it by hand using the formula, this is the formula that needs to be used. Let's go over some examples. In a clinical study of an allergy drug, 108 of the 202 subjects reported experiencing significant relief from their symptoms at the 0.01 significance level. There is the claim that more than half of all those using the drug experience relief. You will realize right away that in this case, we don't really have a lot of information. Some will say, you know what? Now I realize I like the problems, long problems with a lot of information because I don't really know what to do with this 108, 202, and that's about it, right? But let's read the problem again and realize that this is a test of the proportion. It's a test that should be done for proportion. Why? Well, first of all, we have number of successes, which we call that X, and number of subjects, which is the total sample size. So in this case, we have 108 successes out of 202 subjects. And if you recall, this can be used to give us actually the statistic as a proportion as p hat 108 divided by 202. And of course, q hat, which is 1 minus p hat. So this is the proportion they reported experiencing relief. Then we have alpha equals 0.01. And then we have to test this claim. Now, what do they want to tell us with this? More than half of all those using the drug experienced relief. More than half. This means more than half or more than 50%, 4.5, right? So right away, we realize that we are dealing with a proportion. So the question is P greater than 0.50? More than half experience relief? This is what we want to test. And it's really important when you read a problem and you know you have to do a test to realize that you are doing a test for a specific parameter. In this case, we're testing the proportion So the test will be done for P, not mu anymore. So let's start the process. The process is the same. Step 1, state the hypothesis. H sub 0, H sub A. Now I'm looking at the given information, and I do realize that I have the population proportion P greater than 0.50, which is the claim, and I write it down as the alternative hypothesis. And at this point, you know why, right? And this will be a right tail test. I write all of it on this line, which means the null hypothesis, the other hypothesis is P less than or equal to 0.5. And that's all I write at the first step. Step 2, I have to decide what distribution do I use. For proportion, we always use the Z distribution. And I will be using a Z test, but because I'm doing proportion, this is called the one prop Z test. And this test will give me the test statistic and the p-value. So this is the command on the calculator. I will also write down what is alpha. Alpha in this case is 0.01. Now at the third step, I'll be actually performing this and find the test statistic or the test value. And the notation used for the test value this time will be a Z, because I'm using the Z distribution, and the p-value. And I can actually sketch the graph. I know exactly how this one looks like. This is a Z distribution. I know this is a right tail test. And right here, I'll have this Z value. And right here, I'll have the p-value. As soon as I find those, I will put those in here. So let's take the calculator, plug in the values, and run the test. So make sure you click on Stats, go to Test, and you will see that right here, option 5 is actually one prop Z test. So you click on 5 or scroll down to 5. And what is P sub 0? Well, keep in mind, it will be the first thing you have in your notes right here, H sub 0, which is equal to 0.50. So I'll just write down 0.5. What is X? Again, the number of successes is 108. What is N? 202. What type of test are we doing? Well, we are doing a right tail test. So if you've done this correctly and you're organized, everything that you need to put in the calculator is right there on your notes. Right tail test. So I will go to greater than, make sure that is highlighted, and scroll down to calculate. These are the values that I have. I have the P greater than 0.5, right? Z is, let's just use a different color right here. It's 0.99. I'll be rounding to 2 decimal places. And P, this will be the p-value actually. That's why they use the prop right here. So there will not be no confusion between these two. This is still a proportion. It's an area. It's called the p-value. That will be 0.1623. So these numbers, Z will be on the Z-axis. This is the number 0.99, the test value or the test statistic. And the corresponding area in that tail is 0.1623. And now we are ready to conclude the test by reaching a decision time. So right here, I will just say, here is how I decide a test based on the p-value. This is actually called the p-value method. I'll take P and I will compare it with alpha. And alpha is right here. And I do realize that actually P is greater than alpha. So what is the decision when this happens? When this happens, I will not reject the null hypothesis. So I can write it down, do not reject or fail to reject. And don't forget what? It's always H sub 0. So we will not reject the null hypothesis, which means we support the null hypothesis. I'm not getting rid of this. So as an interpretation, I'll write down at alpha equals 0.01 level of significance, there blank enough evidence to blank the claim and put it in context. Let's look at where the claim is. Here is the claim that more than half of all those using the drug experience relief. You simply write that down here. I'll let you do that. I'll just simply say P is greater than 0.50. So How do I fill this in? Whenever you fail to reject, you should start with there is not enough evidence to, and think about it. Or look in that chart, you support H sub 0. You do not reject H sub 0. That means you will not support this one. So you do not have enough evidence to support the claim because H sub A was the claim. Okay? Well, I hope this makes sense. Just pay attention to the symbols. Use P if you're doing a test for P. Use mu if you're doing a test for the mean. Let's do another example. Your statistic instructor claims that at least 60% of all students who take elementary statistics go through life feeling less intimidated by the daily barrage of numbers from the media. For some reason, he can't quite figure out why people don't believe him. You decide to check this on your own. You randomly survey 64 of his past elementary statistics students and find that 34 feel less intimidated by the daily barrage of numbers. Now, what do you think? Use 0.05 level of significance to conduct an hypothesis test. Let's write down the given information and conduct an hypothesis test for proportion. This is what he claims. So this is the claim. Now we should know what that translates into. P is greater than or equal to 0.60. So right away you know this is a test for proportion. So this is the claim. The sample size is 64. So N is 64. And the number of successes, X, is 34. Alpha, it's 0.05. The question is, what do you think? Well, we will run a test and we will see if we have enough evidence to support this claim or not. And make sure you know you are doing a test for P, the true population proportion. Let's do so. First step, set up the hypothesis, H sub 0 first, H sub A second. I look at this, and because this one contains the equal sign, I will make that the null hypothesis. And this is the claim, so I write down this is the claim, which means H sub A will be P is less than 0.60. And right away, I have direction of the test or the type of test, which is a left-tailed test. Step 2, this is a proportion test. So right away, I write down this is a Z distribution type of test. I'll be using the Z distribution. I'll be using actually the one prop Z test on the calculator to come up with the results. If I want to use the formulas, I know that I have to plug in the numbers in the formulas, but for us, we will be using the one prop Z test. Alpha, we wrote it right here, 0.05, and we're done with step 2. Step 3, let's actually run the test and find the test statistic or the test value. Let's just write down now value. We used statistics so many times. This will be a Z value on the calculator and the P value, which will be displayed on the calculator. So here we have our calculator. I'll go back to stats and I'll pick the one prop Z test, which is option 5. I'll plug in the corresponding number. P0 is the equality that is displayed in H sub 0. So in this case, it will be 0.60. The number of successes, I have 34, and the total number in this case was 64. So 34 out of 64, they say they feel less intimidated by the numbers from the media. This time we are doing a test, which is the left tail test. So I will pick the middle one, hit enter, right? Less than, it's right here in H sub A. Let's scroll down to calculate. Here are the results. I write the results down right here. Z is negative 1.12 and P is 0.1308. Okay, now P hat, it's as simple as X over N, right? They display the P hat too. This is the probability of success if you need that. If I were to sketch the graph right here, I have a Z distribution. This is a left tail test, so I expect this tail to be shaded. Right here, I have the area, which is 0.1308. And right here, I have the negative 1.12. Okay, now I have all the calculations and I am ready to actually reach a conclusion, and then interpret in this context. Here we go, decision time. In order to decide, I'll simply have to look at the p-value and the alpha value. So I compare this starting with the p-value, and I do realize that the p-value is actually greater than alpha. So I will say, because of that, I will not reject or fail to reject. Make sure you say what, H sub 0. So again, look at this. We ran into a test where we do not reject H sub 0. That means we will enough evidence to support H sub 0, which means we will have evidence to reject H sub A. Let's see how do we put this in context. And this is actually the most important part, how we interpret. You may want to stop the video and try it on your own, and then check with what I have here at alpha equals 0.05 level of significance. There, blank enough evidence to blank the claim that the proportion of students who feel less intimidated by the daily barrage of numbers from the media is at least 60%. So I will let you put this down. You simply have to copy this phrase from here, the whole thing, to put it in context, to make more sense of why statistics is actually so close. It's actually part of our daily life. I'll just simply write down P is greater than or equal to 0.60. When you have failed to reject, you will always have the first part is not. Now, are we rejecting the claim or are we supporting the claim? We are supporting the claim, right? We do not reject the claim. So we do not have enough evidence to reject. We are not rejecting the claim, okay? Oh, I hope this makes sense. Thanks for watching and learning, and this concludes the video.